Okay, so yun. Last time we were able to have an orientation and talk about the um, kung ano yung mga pwede i-expect sa Anachem, no? So, we saw last time that Anachem is really important because it relates other fields of sciences, no? Kasi this subject answers the question what and by how much, no? So, yun, lahat ng field of inquiry, lahat ng field ng science, yun yung usual questions, especially when you are pertaining to matter. So, nakita natin last time na yung Anachem ay very important, no? So, ngayon, let's focus on our main topic for the laboratory. Okay, so this is chapter 0. Let's have an overview of analytical chemistry and let's talk about the tools of trade, no? So when you say tools of trade, these are the things that we do in the laboratory. Um, However, virtual lang tayo, kaya maganda pa rin na may knowledge tayo about this na kahit virtual kasi in the future babalik din naman tayo sa school natin na. Okay. So let's have an overview ng of analytical chemistry and the tools of trade, okay? So when we are doing laboratory experiments, we are expected to have or to wear the following, no? So, lab gowns, laboratory gloves, safety goggles, closed shoes, and tied long hair for the ladies, no? Bakit kailangan nakaganito yung outfit pag nasa laboratory? Because we are dealing with chemicals that are very dangerous for at some levels, no? There was this time na ako bilang chemist, so ibig sabihin madalas akong exposed sa laboratory during my college days, no? So, there was this experiment na we are dealing with a carcinogenic chemical pala. So, when you say carcinogenic chemical, nakaka-cancer. So, if you do not wear the proper protective equipment, no? Personal protective equipment or PPE, pag hindi kayo nagsuot ng ganyan, puwedeng yung hazardous chemicals makaapekto sa iyo and may cause you harm, 'no? Ayan, so yun. Yung thesis ko, I dealt with lead which is highly carcinogenic. So imagine if yung lead tumalsik sa akin, in the near future, baka magka-cancer na ako, 'no? And that's possible, 'no? Kaya kumuha ako ng insurance. Kasi that's life, 'no? Kasi gano'n yung buhay naming chemist. You risk your life for new knowledge, 'no? So, sa medtech, ganun din, no? Kasi, you are dealing with human chemicals, no? Yung mga serum from humans, which is hindi nyo alam if wala bang sakit or meron, no? Especially during these times, no? Ngayong COVID-19, kailangan naka-PPE talaga kayo, no? Kasi, kahit isang droplet man lang yan tumalsik sa inyo, that may cause you harm, no? Puwede kayong maging positive sa COVID, 'no? Isang droplet lang, puwedeng gano'n yung mangyari, 'no? So that's why when we are in the laboratory, we should wear the our personal protective equipments or PPEs and kailangan i-take note natin na it should cover our body, 'no, most of our bodies, 'no? Ayun. Kasi we are trying to avoid spillage, 'no, or yung mga talsik-talsik from the chemicals, 'no? So yan lang. Ito naman yung mga ways of handling chemicals, yung ethical handling niya. Okay, so when you are doing chemical experiments or chemical laboratory experiments, you should be familiar with what chemicals are you working on with, no? Kailangan alam nyo kung ano yung mga chemicals na hinahawakan nyo, okay? So, kunwari, salt yan, edi okay lang, salt. Pero kunwari, may unknown chemical dyan, dun kayo mag-worry, no? Kunwari, may chemical kayo na ngayon nyo lang narinig. So, ang kailangan nyo gawin is, you should be able to look up for its MSDS, no? Ayan. So, MSDS Material Safety Data Sheet, no? So, nandun yung information on the identity of the substance, how to handle it, no? If you suddenly, digested it, ano yung mga pwede gawin, no? Should we bring you to the hospital? Nakalagay doon, no? So yan. So kailangan you should be able to know the MSDS of your chemicals, no? Ito, thesis ko rin to, no? Um, Share ko lang. Kasi yung isang, excuse me, yung thesis ko masyado talagang deadly siya, no? Yung, yung solutions na wino-work on ko ay, bukod sa may carcinogenic, yung lead, the other chemical is acrylamide, which is neurotoxic, no? So, according to the MSDS, mapatakan ka lang nun, pwede kang mamatay agad, no? Okay. Because the acrylamide molecule is very reactive, no? It reacts with your nervous system. Pwede niya i-shut down yun instantly. So, medyo scary yung thesis ko talaga nun. Kaya, yun, kailangan alam mo na yung acrylamide na yun ay delikado, you know. Hindi naman lahat ng tumatalsik sa sa laboratory na clear ay water, no. May mga chemicals na nakahalo doon, no. So yun, kailangan alam niyo yung identity ng chemicals niyo, ano yung pwedeng harms na i-cause niya, and how to prevent those risk, no. So yun yung mga requirement kapag kayo ay mag-work sa laboratory, no. So may experience nyo rin yan in the near future pag nag-lab na tayo. Okay, so be familiar with the substances. Yung molecule, tiny lang yan, but it can kill every one of us, no. You just have to be careful. Okay, pwedeng slow death, pwedeng instant death, no. Pero ang mahalaga, unahan na natin yon. Kailangan alam natin kung paano mapipigilan yung ganong cases, okay? So, for example, ako, buhay pa ako, okay? Despite na ang dami kong chemicals na ganon, no? Na encounter, no? So, you just have to be careful, no? Of course, foods and drinks are not allowed in the laboratory, of course. Bakit? Kasi imagine nyo, hindi nga tumalsik sa inyo, tumalsik naman sa pagkain nyo or sa tubig nyo. Hindi ganun din, di ba? So, you have to be, etong etong ano na 'to, etong profession na 'to, 'yan yung kailangan talaga natin, gawin 'no. Yung ibang students kasi ang ginagawa ay kapag laboratory, kunwari wala silang ginagawa, kakain sila 'no, and that's wrong 'no. Ako, during my college time, if I'm working on my laboratory experiment talaga, hindi ako kakain hangga't 'di siya tapos 'no. Even if it means na not eating from 7 AM to 9 PM. Nangyari sa akin thesis, siyempre gusto ko graduate. So, you have to ano you have to control yourselves, no? But kung may ano ka naman, may mga friends ka na or thesis mates na tutulong sa inyo, edi gawin niyo ano. Just so happen na yung thesis mates ko, alam niyo na, hindi ko sila dama. Kaya nag-solo talaga ako. Okay? So, ganun ha. You have to control yourselves. Pag nagugutom na, tiis muna. Okay? Kasi when you work in the industry, ganun din ang buhay. Okay? So, except that you have to eat talaga by 12, no? Kasi yun yung mandated by the law. Okay? So yun, you have to be careful. Kasi yung chemicals, hindi lang yan pwede tumalsik sa inyo, pwede yung tumalsik sa food and sa drinks ninyo. No? So avoid drinking even inside the laboratory. No? Kahit bottled water yan. No? Ako ginagawa ko pag iinom na ako ng tubig or kakain ng snack, lalabas talaga ako. I will remove my PPE kasi baka makontaminate yung food ko. No? Tapos pagbalik, suotin mo na lang ulit. Next one, contact lenses are not recommended. No? I've been using contact lenses, no? Pero kapag laboratory, I use glasses. Bakit? Kasi yung ating contact lenses, imagine nyo, kunwari may fume, may usok, no? Yung usok na yun, di natin alam kung may chemical doon na nakahalo and it may go into our eye, no? Tapos, alam natin yung contact lenses natin, medyo nag-store yan ng dirt talaga. Kaya nga every now and then, nililinis natin yan, di ba? So, if yung dirt na nakapasok sa contact lens natin ay hazardous chemical pala, edi wala rin silbi yung ating PPEs, no? So that's why I do not advise you to wear contact lenses, although maganda siya tignan kasi colored yung eyes natin, ganun din ako nung college. Pero yun, hindi siya advisable because we are dealing with ano, with hazardous chemicals sa lab, no? Okay? So, mag-ingat tayo. So, do not use contact lenses. Instead, pag nasa laboratory, mag-eyeglasses kayo. Okay? Tapos, pwede nyo pa picture ang sarili nyo, no? Nerd tignan, no? Kasi pag contact lens, delikado talaga. Although comfortable siya, no? And also, sometimes we deal with chemical reactions that involves heat, no? Pag nainitan kasi yung contact lens natin, naiirita tayo, 'di ba? Ako, madalas ako ganun eh. So, ayaw natin yung ganun, no? Yung uncomfortable tayo when we are doing experiment, no? So, just wear your normal eyeglasses, no? The next one, if you're dealing with organic solvents, acids, or ammonia, they should be handled in a fume hood, no? What is a fume hood? That is just a an instrument, no? Enclosed instrument siya that has a vacuum, no? Meron siyang exhaust fan sa loob, no? Bakit, no? Kasi when you deal with organic solvents, acids, or ammonia, super strong ang smell nila. And hindi lang super strong, it is also dangerous, no? Pag nalanghap nyo yan, it may cause um, lung disease, no? So, ayaw natin mangyari yon. So, lahat ng smoke, lahat ng usok sa chem, hindi yon sinisinghot, okay? So, hindi lahat sinisinghot sa lab, no? Kasi delikado. So, you should place your chemicals in the fume hood so you will not have any sort of lung disease, no? Mahirap na. And then, when you have spillage, no? Please clean it, no? ASAP, no? Kunwari may nakita ka, uy, tubig lang yan, okay lang yan. No, punasan nyo, wipe it out na. Kasi hindi mo sure kung ano yung nandun talaga, no? So, that's why you have to have your tissues always, no? Okay? So, nangyari sa akin to sa lab din, no? Siyempre, 4 years na lab, every sem namin sa chem, naglalab talaga kami. So, matagal-tagal din yun, no? 4 years na tuloy-tuloy na lab, no? So, nangyari kasi sa akin dito is that, sa akin naman, experience ko, may classmate ako, nag-work siya with, titration, which requires acids, no? Acid-based titration kami noon eh. May isang patak, may maliit na patak na nandun sa desk. Tapos naka-PPE ako. Eh, syempre, dumidikit tayo sa desk, no? Tapos yung patak na yun, nadikit sa damit ko. Nagulat ako one time, bigla lumaki yung butas ng damit ko, yung PPE. Kasi super strong acid pala yun. Actually, yun dito siya sa loob, nasa bahay siya. Tignan ko lang. Nasa loob ng baul eh. Pero yun nga, no? Tinabi ko, di ko siya tinapon kasi memorable yun sa akin eh. Imagine, isang maliit na patak lang yung damit ko, yung lab gown ko, nabutas siya ng sobrang laki because of that acid, no? Siyempre, nagalit ako sa classmate ko, no? Bakit naman ganito, ganyan, blah, 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 no? Pero ang lesson doon is that, yun, anytime na may makikita kang droplet sa lab, please wipe it, no? Kasi mahirap na, okay? Tapos, yun, wear your PPE. Kasi imagine nyo, what if sa damit ko agad, tumalsik yun, edi yung acid, dumiretso sa balat ko, nasunog pa yung aking, skin, di ba? Sayang yung skincare ko. So, ganun lang. So, yan. And yan, if you have any spills, kunwari, natalsikan naman kayo sa balat, hindi natin in-expect na nangyari na talaga yan. So the first thing you have to do is to flood it by water with water, no? So kailangan ang laboratory may adequate amount of water siya, good stream of water. Gagawin nyo yung part na natalsikan, ifa-flush nyo lang with water around 10 to 15 minutes, ganun katagal. Ubos siya sa ubos sa tubig, pero yun yung recommended para malinis talaga yung area. Okay? Then, first aid should be available. We should know how to use first aid. Kahit band-aid man lang yan or gauze, kailangan alam natin how to use that. Na? And then, you label all the chemicals. No? Label everything na paglalagyan nyo ng chemicals sa laboratory. Okay? Kasi ganito, pag nasa lab kayo, to be honest with you, sometimes you will have to use water bottles to serve as your containers. Baka isipin nyo naman, ay, ang careless naman nun. Hindi. Ganun talaga yung totoo. Yung inuminan nyo ng tubig. darating yung time na yun yung gagamitin nyo pang-contain ng chemicals. Yes. Okay. Ano yung risk doon? Kasi kapag hindi nyo tinanggal yung pangalan na, kunwari, pH 8, di ba may ganun? pH 9 ba yun? pH 8. Yung kulay red na bote. Kunwari, hindi nyo tinanggal yung takip na yon. Tapos nakita nyo ng ibang tao, uhaw na uhaw siya, pwede niya mainom yon. So, ang kailangan nyo gawin, tanggalin nyo yung label ng commercial brand ng water bottle. Tapos palitan nyo yun ng name ng substance na nilagay nyo doon. Okay? So, nangyayari talaga yon sa laboratory, no? Kasi may mga bagay na hindi natin ina-expect na kailangan pala ng container. Okay, so that's normal. Pero yun nga, lagyan nyo siya ng label. No, always lagyan ng label. Pag walang label, mahirap na. Okay? So, nangyari din yan sa lab ko. Although, student ako noon, college pa ako niyan. Hindi naman sa amin nangyari sa BS Chem kasi syempre alam namin kung paano mag-deal with chemicals, no. Nangyari siya sa food technology. Nakwento-kwento lang to sa amin eh, chismis lang. Although nung pumunta ako dun sa part na chismis, nakita ko nga yung bakas ng nangyari. Okay. Bakit? Kasi ganito nangyari. May bottle, no. Tapos, ginawa pala doon, yung student, naglagay siya ng chemical sa bottle na acid. Okay, acid. Strong acid siya actually. Kaso, yun nga, hindi niya pinalitan yung plastic, yung container, yung label ng commercial bottle na yun. Hindi niya tinanggal, no? Hindi niya nilagay, concentrated acid to, ganito, ganyan, blah, blah, blah. Or 0.1 molar ng sulfuric acid, let's say. Hindi niya ginawa yung ganun, no? So, anong nangyari? Ito daw, may classmate siya. Sabi niya, "Uy, besh, painom." Ginawa ng babaeng yon, kinuha yung bottle na may acid. So, pagkapasok sa bibig, uminit yung bibig niya, dinura niya na. Tapos, alam ko, sinugod siya ata sa ospital eh. Although, hindi naman matindi yung hindi naman matindi yung yung burn, no? Ano lang, uminit lang daw. Pero safe naman siya generally. Okay. So nangyari yung ganong case, no. Pwede niyo mainom yung chemicals na hindi niyo alam kung ano yung nandoon because of mislabeled containers, no. So kailangan lagyan niyo talaga ng labels lahat, no. Okay? Pero it is very advisable if may proper containers kayo. Pero I will tell you, there will be times na gagamit talaga kayo ng bote. And that's normal. Okay? So, yan. Ganun ka-importante ang label. Okay? Next one is to dispose your chemical waste properly and responsibly. Kasi tayo sa science, we are not just enriching our lives, no? Nor the lives of the people. We should also, take care of the environment, no? So, hindi lahat ng tinatapon natin ay dapat itapon sa sink, no? So, there are chemicals that may cause harm to the ecosystem. Pwede siya mag-cause ng, imbalance sa ecosystem. So, hindi lahat tinatapon, no? Especially if medical waste yan, okay? So, if medical waste yan, hindi mo siya agad pwede itapon-tapon, no? Kunwari, dugo yan, hindi mo yan pwede ibuhos agad sa sink, no? Pwedeng maging yan, pwedeng maging cause yan ng biohazard, di ba? What if may iba pang disease yung blood na yon? Di kumalat lang yung disease, no? So you have to treat your chemicals first, no? So when treating chemicals, madali lang yan, no? Uh, Understanding of basic chemical reactions lang, that will help, no? O kaya, use your understanding sa biology, no? Pwede ka mag-autoclave muna before you dispose it, no? Para wala nang harm, patay na yung mga bacteria, no? So, yan. You have to dispose your chemicals responsibly because hindi nga siya naka-harm sa inyo, naka-harm naman siya sa ibang tao. And that's bad, no? Very, very bad. Okay? Nangyari to sa United States. Ito na yung movie na sinasabi ko sa inyo last time. Sabi ko ba sa inyo? I don't know if nasa Netflix siya. Pero pakita ko sa inyo yung Pwede yung siya panoorin actually. Maganda siya. Comedy. Brockovich. Yan. Ito. Actually, siya ay totoong tao to ba? Okay. Tapos may movie siya. Pangalan ng movie ay Erin Brockovich. If you're familiar with her, good. If you're not familiar with her, okay lang din. Okay? Pero maganda yung panoorin. Panoorin nyo na lang by weekend. So, ito si Erin Brockovich. Ano siya? Isa siyang normal na tao. Normal na tao lang siya. However, sa kanilang area, sa kanilang village, napansin niya, ang dami nagkaka-cancer. Ang dami nagkakasakit. Then, upon her investigation, nalaman niya na yung isang company, itong Pacific Gas and Electric Company, ito ay naglalabas ng hazardous chemicals without treatment, no? So, ano lang, basta-basta lang nila tinapon yung chemicals na ginagamit nila sa waterways, no? Na nangyari, humalo siya sa ano, drinking water, edi ano nangyari? Nagka-cancer yung mga tao. And yes, true to life 'yan, no? So, 'yan. So ginawa niya, nag-file siya ng lawsuit against this very big company and she won, no? Despite na wala siyang knowledge about law at first, no? So, 'yun. Magandang movie 'yan, no? Erin Brockovich, no? So, doon natin makikita yung implication ng ginagawa natin sa lab, no? Kapag basta-basta mo na lang tinapon yung substances mo, okay? Hindi ka nga namatay, yung ibang tao naman yung madadali. No? So, ayaw natin yung ganun. Okay? So, ang scientist, hindi tayo selfish dapat. Kailangan iniisip natin yung ibang tao. No? No? Isang maling galaw lang, pwede silang madali. No? So, yan. So, yan. So, we're done with the, with the introduction lang sa lab parts. Yung mga do's and don'ts sa lab. So, you have to wear your PPEs. And you have to take note of the ethical handling of chemicals, no? Okay, so always read the MSDS. Andyan lahat ng info kung paano i-deal yung chemicals natin. Okay? Ngayon, punta na tayo sa excuse me. Punta na tayo sa tools of trade, no? So when you say tools of trade, hindi naman yan yung trade na bentahan, no? We are pertaining to the tools that we use in Anachem, no? Yun, mga tools na ginagamit natin sa Anachem, no? Paano tayo gagawa ng isang chemical analysis, no? So these are the common tools that we use in Anachem, no? Number one, you should have your lab notebook, no? Yung mga nanalo ng Nobel Prize sa chemistry, physics, may mga lab notebook yan. So, kung gusto nyo manalo din ng Nobel, magkaroon dapat din kayo ng lab notebook. No? Why? Because part ng life natin as scientist, no, or researcher, or future doctors, no, um, part ng life natin is to log kung ano yung nangyayari sa lab. No? Because you will need that in the future. Okay, especially when you are doing lab reports, when you are doing publications, no? Journal articles. So, kailangan may lab notebook. So, you will have a reference material kung ano yung nangyari sa lab, no? What went wrong, kung ano yung umokay, and what are the results, okay? And it should be understandable by strangers, no? Bakit? Kasi mamaya yung handwriting niya very sloppy, hindi na maintindihan ng ibang tao, maski ikaw hindi mo na maintindihan, no? So treat your lab notebooks as your diary, no? Alam ko wala na nagda-diary ngayon, ako rin naman hindi nagda-diary, pero yung idea lang na maganda yung sulat natin doon. Yan. Yun yung important with the lab notebook, okay? Yung ibang students nga, ginagawa pa, nilagyan pa ng borders, and that's okay, no? Mahalaga, maintindihan nyo kung ano yung nakalagay dyan because later on in your life, you will need that, no? Nung thesis ko, dito pa yung ano ko, yung lab notebook, no? Pag tinitignan ko siya last time, no, sabi ko, ay, ayoko na mag-college. Ang daming stress sa buhay, no? Pero andun pa rin yung info, o ito yung ginawa ko. Tapos naalala ko yung galit ko sa mga classmates ko. Sa ganun. Parang naging diary ko na rin siya nun, no? Okay. So, the next tool that we will use in Anachem is the analytical balance, no? Analytical balance is a type of weighing device, no? However, it has a precision up to 0.0001 0.0001 grams, no? So it can measure up to 1 times 10 raised to negative 4 grams, okay? Or 0.1 milligram. So ganun siya ka-accurate, no? So this is an electronic device that uses magnets, no? And depending on the flotation or the current induced by the weight of the substance, makukuha niya yung accurate mass. Okay? So, ito yung very accurate na timbangan sa Anakem. Kaya nga analytical balance gamit sa kanya because we use it in analytical chemistry. Maraming uri ng balance sa chem. We have the top loading balance, the triple beam balance, and the analytical balance. So, ano yung examples ng top loading balance? O, yun yung mga nasa palengke. No? May mga analog versions pa nga, no? So, yun yung ano, it can measure only up to 0.5 kilo or 0.0 ano, or let's say 10 grams. Hanggang doon lang yung limit niya. Kitchen, ano, yung kitchen scale. Ganon din, or body scale. Hanggang doon lang limit nila. Hanggang 0.1 ng kilogram or up to 10 grams lang. Hanggang doon lang yung range niya. But if you are dealing with very, very tiny amounts of substances, you have to use a much more sensitive instrument such as analytical balance. Bakit? Kasi sa Anachem, we are using ano, as in gapiranggot lang ng chemicals, no? As in pinch lang. O, paano mo titimbangin yung pinch? Pag nilagay mo yun sa timbangan, di nga magre-register yun eh, no? So you have to use a very sensitive instrument, no? In order to accurately measure your substance mass. Okay? So yan. And, ayan. May proper use yan, pero syempre mas maganda kasi yan pag nasa lab mismo. Ano pa mapapansin natin? Analytical balance is enclosed, no? So, ibig sabihin ng enclosed, may takip talaga yan all throughout. Meron dito sa sides and sa top. Why? Because even a small, ano, kapag, onting breeze lang ng hangin, mame-measure niya yon. Pag binugahan mo yan, magbabago yung mass niyan, no? Kasi ganun siya ka-sensitive, no? It can even measure the force exerted by the wind, no? So, kaya kailangan enclosed siya para hindi siya mahanginan, no? Para hindi magbago-bago yung measurement. No? Okay, so ganun siya ka-sensitive. Okay? So, next one is the burettes, no? So, burettes are tools that are used to transfer liquids, no? And we mostly use this kapag tayo ay nagta-titration. Okay? Titration. So, yan ay ginagamit sa titration. These are tools na ginagamit to transfer precise amounts of liquid when doing titration processes. No? At makikita natin, meron siyang graduations. No? When you say graduations, may label, no, ng volume. No? Okay? So, how do we use burettes? No? So, of course, when you are using your burette, you have to wash it with your solution. No? And then you eliminate any air bubbles. Para lang yan syringe. No? Kailangan, di ba, walang bubbles pag syringe. Ganon din dito sa Anachem. Yung mga bubbles, we will try to eliminate all of them. Kunwari, ganito kasi yun eh. Yung water ilalagay mo dito or yung liquid lalagay mo dyan, then i-drain mo siya dito sa stopcock. No? So, tutulo siya palabas. If it happens na may air bubble dyan, ang gagawin mo, ifa-flush mo pa rin siya. No? You twist the stopcock until it opens, until the air bubble is pushed outside the instrument, no, or the tool. Okay, so it can deliver as accurately as 0.1 ml. Okay, so up to that lang ang limit niya. Okay, so also since this is a volumetric instrument, meaning it deals with liquids, no, you have to read the measurement sa lower meniscus parate, no. So for example, kasi ganun yung liquids talaga, nagko-concave meniscus yan, 'di ba? 'Di ba sabi natin last time dalawa yung uri ng meniscus, convex and concave depending on the intermolecular forces, no. Ang ginagamit naman natin dito sa sa Anachem ay mga water, no? So usually concave meniscus talaga yan, no? So ganun, pag naglagay ka ng liquid, always read at the lower meniscus, no? Kunwari, ito may reading dyan. Yung lower meniscus yung titignan, not the upper meniscus, no? And avoid parallax errors, no? When we say parallax errors, these are errors because of the point of view, no? Kailangan, if you are going to look at the lower meniscus mark ng burette, it should be at eye level, no? So kung nasan yung meniscus, andun din dapat yung mata nyo. Kailangan pantay. Kasi pag tinignan nyo yan, at pag nasa baba yung lower meniscus from your eye, parallax error yon. Ibig sabihin mali yung angle ng mata. Pag tinignan nyo naman yung meniscus na nasa taas ng mata nyo, nakaganong kayo, mamamali rin kayo ng reading, no? So, kailangan, in order to avoid parallax errors, kailangan the meniscus is at your eye level, no? So, if you have to bring down your test tube tuloy. If you have to bring down your burette from its clamp, kailangan nyo gawin, no? Minsan nga ginagawa ng students ko, gumagamit pa sila ng upuan, no? In order to see the meniscus at eye level. So okay lang 'yon, but just be careful na. Maski ako ganun eh. So ganun. Minsan tatanggalin ko pa siya sa niya holder, sa clamp para makita ko at eye level, no? So never titignan mo siya na nakatingala ka or nakayuko ka. Kailangan pantay lang. Okay? And when viewing meniscus pala, hindi nyo tatakpan yung isang mata nyo. Hindi kayo nakaganon or nakaganon. Kailangan dilat yung parehas na mata. Okay? So, part din kasi yun ng parallax error. Kailangan dalawang mata yung gumagana sa pagbasa ng meniscus. Okay? Next one is the volumetric flask. No? So, volumetric flask, this is a tool which we use in preparing solutions. No? Kung ito, ang burette, this is used for transferring liquids, no? Transferring solutions. Ang volumetric flask, ito ay ginagamit to prepare solutions, okay? So, ito yung unang-unang gagawin nyo sa lab, no? So, gagawa kayo ng solution. So, ito yung gagamitin nyo, volumetric flask. No? So, volumetric flask is an instrument that is calibrated to just one volume measurement. No? So, isa lang yung volume na pwede niya gawin. Meron niyang 50, meron niyang 100, meron 250, may 500, and may 1 liter volumetric flask. So, hanggang dun lang yung versions niya. Okay? So, kunwari, ang thesis mo, kailangan niya ng 800 ml ng ganitong substance, gumamit ka ng 500 ml na vol flask, 200 ml, or 100 ml. O kaya pwede naman yung 1 liter na lang. Saka ka na kumuha, no? So, fixed yung volume dito. Okay? Bakit siya fixed? Kasi iisa lang yung graduation dito. Sa neck, okay, so dalawang part yan. Ito yung neck, no? Tapos ito yung ano ba tawag dito? Basta yan. Basta ito lang yung neck. Hindi ko alam kung ano tawag sa baba. Kalimutan ko na. So basta nandun sa neck yung nag-iisang mark, no? Very thin line, no? Na pag na-reach mo yung lower meniscus doon, ibig sabihin 500 ml na yan or 100 ml na yan. So hanggang doon lang siya. Okay. Pag lumagpas ka dyan, uulit ka uli. Okay. Pag kinulang ka, didagdagan mo ng tubig. Pero again, kapag lumagpas yung tubig mo dyan, ulit ka uli from the top. And yes, ang laki ng struggle namin dyan dati. Okay. Kasi kahit onting lagpas lang, mali ka na doon. Okay, so ulit ka talaga. Kailangan properly aligned ang lower meniscus sa mark. Okay, sa line. Okay. So, how do we prepare solutions using volumetric flask? So, ganito lang yon. Di-discuss din natin to next week, no, sa solutions chapter. Okay, so ganito lang mag-prepare ng solutions. You have your volumetric flask, okay? You place your solutes or your solid na gusto mo i-dissolve, no? Kunwari, nag-weigh ka, I need 5 grams, edi ilagay mo yung 5 grams lahat dyan. Okay? Then, after that, you have to use wash bottle, no? So, wash bottle, yan ay container ng liquid na pwede mo siya gamitin pang squirt, no? Okay? Bakit wash bottle yung preferred, not just yung tap water, no? Kasi kapag wash bottle, you can use the nozzle to clean the ng area dito sa neck, no? Pwede mo siya gamitin panlinis ng neck. Kunwari, kapag yung crystals nyo dumikit sa neck, so kailangan yung crystals na nandito, mai-push mo siya pababa, no? So you can use the wash bottles nozzle to push those crystals pababa, no? So kailangan malinis yung neck. Kailangan lahat ng crystals nasa baba. Then you will fill it halfway. Halfway lang muna. Ano gagawin nyo? If you-fill nyo yan halfway, ganyan lang muna. Takpan nyo siya with a stopper. Then, iswirl nyo siya. Iswirl it until all the crystals are dissolved, no? Kasi kapag pinuno nyo agad yan, mali yan. Mali kayo doon, no? So, kailangan iswirl nyo muna siya. Okay, fill it halfway. Swirl until it is all dissolved. Actually, pwede mo siya bali-baliktarin, no? O, kunwari, ito yung ito yung ko, vol flask, no? Volumetric flask. Pwede mo siya bali-baliktad. Just make sure na walang magi-spill na liquid. Okay? So, ganun lang. Kaya nga may takip yun sa taas. Kasi pwede mo siya bali-baliktarin in order to dissolve as much as crystals as possible. Okay? So, once they are all dissolved, you can fill the remaining parts of the ball flask up to mark na. So, kailangan up to mark kasi kapag lumagpas ka dyan, uulit ka uli, no? Sayang yung chemicals and sayang yung time. Usually, when you prepare solutions, it will take around, let's say, 10 minutes, no? Depende pa sa struggles mo, no? So, ako, 10 minutes talaga. Pero, I ensure na isang gawaan ko lang ng solution, tapos na ako. So, yan. You really have to be careful with preparing solutions. Next one is pipets and syringes. No? So, these are tools that are used to transfer liquids. No? So, ito yung pipettes natin, and it has volumes. It can transfer as little as 1/10 of an ml. No? So, pwedeng 1/10 ng ml lang pwede niya i-transfer. Pwede ring up to 20 ml. No? Up to 20 ml yung kaya niya. Yung syringes naman, ganun din. Pwede mo ito gamitin pang-transfer ng liquids, no? Sino sa dalawa mas accurate? Of course, yung pipette, no? Okay, bakit yung pipette yung mas accurate? Because of the graduations. Mas marami siyang mark compared to the syringe, no? Nasa baba yung syringe ko dito, eh. Okay? So, punta tayo sa pipettes. Pipettes are used to deliver known volumes of liquid, and ang mangyari dyan, may dalawang uri ng pipette, no? We have a transfer pipette and a more pipette, no? Ano yung difference ng dalawa? When we use transfer pipette, it can only deliver one specific volume. Kasi iisa lang yung mark niyan, eh. So you have to fill it up to this mark, meaning non 10 ml yon. Then yun lang yung pwede niya i-transfer up to 10 ml. Eh, kunwari, ang gusto nyo, sir, gusto ko 5.5 ml. Pwede ba yun? Pwede naman. You have to use a more pipette, no? More pipette, M-O-H-R, is a version of pipette that has graduations, no? So, ayan. So, hindi lang siya specific to one volume. It can transfer as many volumes as indicated here in the graduations, no? So, kunwari, gusto mo 5.5, edi transfer liquid up to this mark, no? So, ganun. And, ito yung kailangan natin i-keep in mind that the last drop should not be blown out, no? Hindi dapat siya binubuga. Kasi, yung instrument na yan, yung last na patak niya, yun yung 10 ml. Pero kapag may natira sa loob, wag nyo siya i-blow. Okay? So, yan. So, ganun lang. Wag i-blow palabas yung mga matitira sa container. So again, ano yung dalawang uri ng pipette? We have a transfer pipette and a more pipette. So when we say transfer pipette, it can only transfer one volume. Isang volume lang yung pwede niya ma-transfer because it only has a mark. No, isa lang yung mark niya. Compare that to a more pipette or measuring pipette. It can transfer kung anong volume gusto nyo as long as pasok siya dun sa sa graduations doon. Usually yung graduations diyan ay 0.1 ang intervals, no. So pwede ka mag-transfer ng 2.1, no, 2.3, no, ml, no. So ganun. Sir, paano naman po kung gusto ko po mag-transfer ng 0.0001 ml? Pwede ba 'yon? Pwede. However, hindi mo na pwede gamitin yung pipette. Bakit? Kasi ang limit nito ay 0.1 ml lang. If you want to transfer 0.00 something ml, no, mas maliit pa doon, you have to use micro pipettes. No? Micro pipettes can transfer volumes up to 1 to 1,000 microliter. Okay? So, ibig sabihin, super liit talaga niya. So, when you say microliter, that is 10 raised to negative 6 of a liter or 10 raised to negative 3 of an ml. So, it can transfer up to 0.00001 ml. So, ganun ka onti yung pwede niya i-transfer. Okay? So, kapag medyo malalaki yung, yung volumes na kailangan mo, you have to use pipette. Pero kapag super onte yung volumes na kailangan nyo, you have to use micro pipettes. And ito yung nakikita nyo doon sa TikTokerist, no? Na microbiologist ba siya? Or chemist siya? Yung yung nasa TikTok na nasayaw-sayaw sa lab. Yan yung ginagamit niya, yung pipette. No? Para yung para yung barrel. Yan yung itsura niya. So, it can transfer volumes of 1 to 1,000 microliters, no? And may mga parts yan, no? So, ayan. So, ito yung micropipette, no? Pero hindi mo siya gagamitin as is kasi may idudugtong ka diyang tip, no? And the tips are disposable. Yung tip na yan. Pwede mo yun itapon. Every time nagagamit ka niyan, papalitan mo yung tip, no? Just to avoid contamination. Okay? Then, ito sa gilid niyan, itong taas na to, actually, ito pwede mo yan iikot, no? Iniikot yan to adjust kung anong volume yung gusto mo i-transfer. So, iikot mo lang yan, mag-a-adjust yung volume, then, once you set your desired volume na gusto mo i-transfer, you have to press it, press it, tapos, i-release mo yon to, to suck out the liquid from your solution. Then, kung gusto mo na siya i-release, i-press mo uli siya. Okay? So, dalawang press yung ginagawa dyan. So, yung unang press, yun yung panghigop ng liquid. Yung pangalawang press, yun yung pang-release ng liquid. So, ito yung ginagamit sa microbiology lab and even sa vaccine research labs. No? So, kung may makikita kang ganyan sa balita or sa TikTok o kaya sa YouTube, micropipettes gamit yan. Okay? So, ito yung tip. Okay? So, disposable yan and it can transfer very tiny amounts of liquid lang. So, ayan. Syringes naman, of course, you can use this to transfer liquids, pero kung kailangan mo yan itusok sa katawan ng tao, mas kailangan mo yung syringe kaysa sa pipette, di ba? So, ayan. So, yung syringe, ito ay may barrel, plunger, and needle. So, ito yung needle, ito yung tinutusok na sa tao, or sa hayop, or sa kung saan man. The barrel contains the graduation, and the plunger is used to draw the liquid or to release the liquid. No? So, yan. And then, when you are using syringe, kailangan yung kukunin mong volume, yung i-withdraw mong volume should be greater than your desired. Bakit? Kasi later on, kunwari nakasak yan ng bubbles, ang kailangan mo gawin ay i-release yung bubbles, di ba? So, kaya nga nakikita nyo sa Korean novel, K-drama, Korean novela tuloy, GMA talaga. Pag napanood nyo yung K-dramas, di ba, ginagawa na sa syringe na taas, tinuntok-tok. Bakit tinuntok-tok yun? To, to push the bubbles papunta sa tip, no? Or bandang nozzle. Tapos pag after nyo siya tuktokin, you press the plunger upwards para ma-release yung bubbles. No? So, bawal yung bubbles. Kasi pag yung bubbles napasok sa katawan ng tao, delikado daw yun, sabi ng doktor sa YouTube. No? So, yun. So, kailangan bubble-free to. Okay? Filtration. So, ang filtration, this is used when we are having gravimetric analysis, no? Kapag magbe-measure tayo ng mass, pag nag-precipitation reaction tayo, if-filter natin yan, no? Para ma-release yung precipitate from the liquids, no? So, usually, we use the Gush filter crucible. So, ito yung Gush filter crucible. Isa lang siyang container. Then at the bottom, meron siyang porous glass. Actually, may butas yung mga yan. No? Then, pwede mo yung lagyan ng filter paper. Okay? So, once andun na yung filter paper, pwede mo lagay yung precipitates dyan. Ito yung precipitates, lagay mo dyan. Then, meron yan vacuum dito sa gilid. No? Pwede mo isak yung liquids. So, mapupull yung liquids from here, pababa, leaving the precipitates here. No? Matutuyo yung precipitates dyan because of the vacuum. Pwede mo yun i-connect sa vacuum or pwede rin naman sa another Erlenmeyer flask. No? So, ganun. Ito naman yung conventional filter paper setup, no? Or common filters setup. Conventional, ito yung high end, no? So, paano yung conventional, you have your, you have your beaker, you have your iron stand, you have your clamp, you have your, tawag dito. Kalimutan ko yung tawag sa glass funnel, ayun. 1 year na ako hindi naglalabi kasi pandemic. So ito, this is your glass funnel, then you will place your filter paper inside it. No? So when placing the filter paper inside it, you have to use origami. No? So mag-art. So usually, we fold the paper in 4. Okay, gagawin mo siyang 1/4. Then, ifo-fold mo siya para maging cone, then you will fit it dito sa filter paper. Then, ito-transfer mo yung solution mo na gusto mo i-filter with a glass rod, no? So, ano yung purpose ng glass rod? Para hindi pakalat-kalat yung liquids, no? Para dun lang siya tutulo sa part na yun, okay? So, yan. Tapos pagkalagay dyan, ayun, madudraw yung liquid, papunta sa receiving flask, no? Due to gravity. Ang downside lang netong setup na to is it depends on the gravity, no? So, medyo matagal to, as in super tagal. May last year, bago mag-lockdown sa FEU, no? So, nagganito kami sa isang experiment namin and it took us around 1 hour to finish the filtration. Kasi super tagal niyan. Okay, kasi dependent ka sa gravity, no? Pero kung gusto mo mabilisan, you have to use this Gush filter crucible. Okay. However, it requires other instruments such as vacuum, no? So, kung walang ganun sa lab, edi ito yung gagawin mo, the traditional. Okay. So, next one is ito yung instrument natin for drying. May oven po sa laboratory. Yes, hindi siya ginagamit for cooking. Pan-dry lang siya ng glasswares or pan-dry lang siya ng precipitates, no? So we place our glasswares or precipitates here sa sa oven. Yan. So minsan yung pagda-dry yung pagda-dry natin ng apparatus ng reagents or precipitates, no? It takes around from 12 hours to at least a day, no? Overnight. Minsan nga 1 week pa eh. Okay, so ganun katagal yung drying, no? So ano yung purpose in drying? The purpose of drying is to remove as much water as possible, no? Kasi even our glasswares absorb water from the air. Kasi 'di ba humid yung air natin. So kahit anong instrument 'yan, mag-a-absorb yan ng liquid from the air. What's the downside with that? The downside is kapag marami siyang inabsorb na water from the air, the mass will be increased, no? it will be heavier. So, ganun yung mangyayari. So, if you want to remove the factor or the additional mass given by the humidity, so you have to dry it, no? So, you have to dry it at temperatures higher than the boiling point of water para mawala yung tubig, no? Epal kasi yung tubig talaga sa chem lab, no? Kaya, kung mapapansin nyo yung ibang chem lab, may mga dehumidifier, no? So, para mawala yung water as much as possible sa hangin. Kasi pag yung water droplet sa hangin, dumikit yan sa instrument mo, bibigat yan. And that will cause errors, no? Kunwari naman, you have to, after drying, saan mo ilalagay yung instrument mo para hindi siya mag-absorb ng liquid? Hindi mo siya pwede ilagay kung saan. No? Say, for example, if you place it at your desk, it will collect water vapors uli. No? So, paano po siya may iwasan? So, in order to prevent that from happening again, you have to use desiccators. No? So, desiccator is a chamber uh, which contains desiccant, drying agent yon. Alam niyo yung, di ba kapag bumili kayo ng new shoes, di ba may packet doon, drying, sabi doon, ginagamit daw yun to dry the shoes. Silica gel yun eh. Yun din yung nandito sa desiccator. Yung nasa sapatos nyo, yung bilog-bilog na, na pang-absorb ng water, yun din yung ginagamit dito sa desiccator. So, andito yung silica gel, yung ginagamit din sa shoes nyo. So, andyan yan. It will absorb the water from your apparatus here. So, dito mo ilalagay yung beaker, dito mo ilalagay yung vol flask, dito mo ilalagay yung watch glass, no? O, kung ano man instrument dinadry mo or kung anong precipitate dinadry mo, ilalagay mo siya dyan after, no? After siya manggaling sa oven. Okay? So again, what's the purpose of desiccator? To prevent the air from from contributing errors sa inyong instrument, no? Kasi may humidity talaga sa hangin, hindi natin may iiwasan yan. So, kung gusto nyo maging as dry as possible yan, you place it in the desiccator because the desiccants here, the silica gel, will further absorb the water, no? Para maging dry siya. Okay? So sometimes we use a vacuum desiccator. A vacuum desiccator, this is better at removing moisture from the air compared to your ordinary desiccator. However, sa FEU, ang meron lang tayo ay ordinary desiccator. No? Maraming ganito doon. Itong vacuum desiccator, ginagamit lang yan for research labs. No? Siyempre, may vacuum. Mahal kaya yung vacuum. Okay? And itong cover na to, actually pwede mo yan slide para yung sa kusina. Naghuhugas ako ng plato parati pero nakalimutan ko yung tawag sa basta yung takip, no. Imagine nyo yan yung kaldero, ayun kaldero. Imagine nyo kaldero yan, tapos may takip. Parang ganun yung desiccator. So ito yung body ng kaldero, ito yung takip niya. However, etong takip na to, hindi mo lang siya basta-basta ilalagay. You have to place petroleum jelly sa paligid. Why? Para airtight siya. Okay? Kasi kapag wala yung petroleum jelly, pwede sumingit yung air sa mga butas-butas, no, sa gap ng takip and sa body ng desiccator. Okay? Ito naman, if you are placing tiny objects sa desiccator, you have to place it in another container, no, just to prevent dust from entering it, no. Kasi yung dust pwede rin siya mag-contribute ng errors sa measurement. Okay? So yan, additional steps, no, pag maglalagay kayo ng instrument, or pag maglalagay kayo ng samples ninyo or apparatus sa desiccator. So yan. And eto na, medyo malapit na tayo sa dulo, no? So the next thing na kailangan natin malaman when we are doing laboratory is that when we are doing laboratory exercises or experiments, we have to know what calibration means, no? Ito, share ko lang, may issue ako with calibration. Bakit? Kasi nga sabi ko sa inyo, last time na nasa mall ako, ang temperature ko daw ay 32 degrees, no? Which means patay ako. Okay. Bakit? Ano ba yung physiological body temp, 'di ba? That's around 36 to 37. Beyond that, may lagnat ka. Below that, patay ka na. Hindi, may hypothermia or malapit na mamatay. So, gulat ako, sabi doon, sabi ng guard, 32 degrees ka, sir. Ha? Pag ganun ako. Siyempre, kinapa ko sarili ko, buhay pa ba ako, no? So, yun yung mali, no? Kasi the problem with, with yung precautionary measures natin during this pandemic is that, yes, marunong tayo gumamit ng instrument. Lahat naman tayo marunong gumamit ng infrared thermometer, marunong tayo gumamit ng ganitong thermometers, digital thermometer. Pero ang hindi natin alam is yung kailangan sila i-calibrate, no? Why do we have to calibrate it? Because when we use our instruments too often, masyado mo siyang ginagamit, ang nangyayari is nawe-wear down yung kanyang yung mga niya, mga circuitry, no. For example, weighing scale 'yan, yung timbangan sa palengke. Bakit kailangan siya i-calibrate? Bakit kailangan siya tatakan ng munisipyo para gamitin? Bakit? Kasi imagine nyo, araw-araw yung ginagamit. What will happen to the spring? Pag araw-araw yan nagko-contract, nag-e-expand. Anong mangyayari doon sa spring ay hindi na siya magiging original. Pwede siyang mas lumaki, no? So kapag naglagay ka diyan ng isang mas pwedeng malaki yung measurement ng weight niya, no? Mare, nilagay mo tong aking wallet. 1 kilo pala yung reading nito doon. Mali 'yun, no? Bakit? Kasi yung mga mechanical devices, they are prone to uh, to yung ang tawag doon. Prone sila sa expansion, no, over time, no. So masyado siyang lumuluwag na. So as a result, mali na yung reading. So ganun din naman yung electronic devices such as digital thermometers, no. Over time, pindot ka ng pindot doon. Oh, ito 32 degrees ka, sir, no. Mali-mali na yung reading na lumalabas doon kasi nagkakaproblema na with the infrared part, no. Pwede sa receiver ng infrared part ng thermometer na yon. So, yun yung problem, no. Gamit tayo ng gamit, hindi natin alam kung paano i-calibrate, no. So, ito yung question. How do we calibrate instruments ba? Okay. So, there are several factors that 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 makes calibration of instruments necessary, no. Ano yung mga factor na kailangan isip para maisip natin na mag-calibrate na tayo? Pag masyado yung ginagamit, you have to calibrate it, no. So, yun. That's true for mechanical devices such as weighing scale. Yung analytical balance, kinakalibrate din po yan, no, against a standard mass, no. So, yan. Kasi habang ginagamit nyo yan, masisira at masisira yan. So, you have to calibrate it, no. So, the next time na may thermometer na ang reading sa inyo ay 30 degrees Celsius, no, buhay pa naman kayo, no. Yung instrument lang nila yung sira, no. So, yan. And you can politely say naman, kuya, pa-calibrate nyo na yung instrument nyo, buhay pa naman ako. No? So, ganun ako minsan. No? Siyempre, kala mo patay ka na. No? So, politely say it lang. Siyempre, pagod din naman sila. Tsaka hindi naman nila trabaho yun. No? Sabihin nyo lang, kuya, papalitan nyo na yung nyo, thermometer. Mukhang sira na. Okay, so ganun lang. So, sa Anakem naman, balik tayo sa Anakem. Kasi dito tayo. Okay. So, in Anakem, we have to calibrate specific apparatus, no? Especially yung volumetric glasswares. Why? Kasi yung glasswares na to, these are used to transfer liquids, di ba? Transfer liquids or to measure liquids to, or to contain certain volumes of liquid. Ano yung problem? Bakit kailangan tayo mag-calibrate? Ang problem ay nasa water. Ang property ng water is that ganito. Depending on the temperature, its density varies. Kaya nga yung yellow, lumulutang kapag yellow siya, kapag 0 degrees Celsius. Hindi siya lumulubog, di ba? Lumulutang siya kapag 0 degrees Celsius, then kapag ambient temperature, kasama na siya ng ibang tubig. Okay? So, yun yung problem. Bakit kailangan natin mag-calibrate? Because of water. Si water ang may kasalanan. Water's density varies depending on the temperature. Okay? So kung makikita natin dito, the density of water is not exactly 1 gram per ml. Hindi siya exactly 1 gram per ml. May variations yan. As you increase the temperature, the density decreases. Bakit? Nag-expand yung water molecules further. As they expand, they will occupy bigger volumes. Hence, the density will be lower. 'Di ba? Remember, inverse ang relationship ng density with the volume. So, habang nag-expand yung liquids, habang tinataas mo yung temperature, 'di ba? Nasa intermolecular forces of attraction 'yon. Pag tinaas mo yung temperature, mag-expand yung molecules kasi nagiging mataas yung kinetic energy nila. So, they will need more room to move, no? So, as it expands, no, at higher temperature, the density will be lower. Habang kapag ang ano naman, kapag binababaan mo yung temperature niyan, yung liquids, magdidikit, yung liquid molecule, magdidikit-dikit, no? So, the density uh, will be higher, no? Until 4 degrees Celsius lang naman. At exactly 4 degrees Celsius, the density is 1 gram per ml. Pero anything below 4 degrees Celsius, tataas uli yung tataas uli yung volume ng liquid, no? So bababa na naman yung density niyan. That's why yung yellow lumulutang kasi tumataas uli yung density pag below 4 degrees Celsius na. So ganun yung trend, no? So parang ito yung 4 degrees Celsius. Ito yung any temperature higher, and ito yung temperature lower. Yung density ay mataas sa 4 degrees tapos mababa sa ibang temperature. Okay? So parang ganyan yung trend, no, with water. And because iba-iba yung temperature ng laboratory, we have to account for that, no. Okay? So yun, we have to account for the true volume of water sa ating container. Okay? So ganun. So ito, example lang to, di na natin to gagawin. Excuse me. So for example, we have this concentration of solution prepared at this temperature. What will be the molarity at this temperature? So magbabago ba yung molarity depending on the temperature? Yes, because um, actually next chapter pa naman talaga to. Bigay ko na, no. Ang molarity kasi, ang formula niyan ay mole per volume. The mole is fixed, no? Fixed yan. Pero yung volume, that changes. Bakit? The density of water changes over temperature scale, 'di ba? So depending on the temperature, magbabago yung volume. So that means at 17 degrees Celsius, iba yung molarity because the volume of water at 17 degrees Celsius is different to that of 25 degrees Celsius. So magkaiba sila ng volume dito. So in order to solve for the corrected uh, for the corrected concentration, you have to make use of the densities, no? Ratio and proportion lang naman. Okay? So you will get this. Hindi na natin to gagawin, ha? Ang gusto ko lang ipakita sa inyo dito is that the volume of water really changes depending on the temperature. Okay? So as an effect, no, yung concentration ng ating solutions nagbabago din. Okay? So for example, at 70 degrees Celsius, ang concentration niya ay ito, 3146. Pagdating ng 25 degrees Celsius, naging 3141. Okay? So mas bumaba yung concentration because the volume of the liquid increased, no? Kasi nga tumaas yung temperature, no? Mas bumaba yung density. Ibig sabihin mas lumaki yung volume. So as an effect, mas bumaba yung molarity. Okay? So yan. So that's why we have to calibrate our instruments parate. Okay? So yun lang. Siguro yung iba sa inyo gutom na, no? Okay? So malapit na tayo matapos, don't worry. So yun lang ang gusto ko sabihin, no? So alam na natin yung mga tools and alam natin na lahat ng tools kailangan i-calibrate, no? Hindi porket may graduation siya, yun na yun. Hindi porket 1 ml yan, yun na yan, no? No. You have to account for the temperature, no? Okay? Pero hindi na natin to gagawin, no? Kasi wala naman tayo sa lab, no? And ito yung pinaka-hate ko na laboratory experiment kasi ang tagal-tagal nito gawin. Okay? Siguro mga 2 weeks kami natapos dyan. Okay? So, yun. Basta ang idea lang is that our instruments must be calibrated, no? So, yun. Okay. And ito, punta na tayo sa remaining steps sa analysis, no? Sa paggawa ng laboratory experiment. So, syempre, magka-calibrate tayo, then measurement. Then, followed by that is that we calculate our results from the experiment, no? So, whether that's titration, gravimetry, electroanalytical methods, or spectrophotometry, after doing all those measurement and calibration, you have to calculate the results. Siyempre, walang study na walang result, okay? So, yun. After obtaining your data, you check ano yung mga implications ng numbers na to. Positive ba to? Negative ba to? So, yun na yung nasa results na. And then, this one is important sa Anakem. You estimate the reliability of your results. So, hindi porket may result ka, okay na yon. Bakit? You have to check multiple times kung yun din ba yung lalabas kapag ibang naman yung nangyari. Kunwari, ibang researcher naman yung gumawa, yun din ba yung makukuha niyang value, okay? Kasi ito yung problem with one experiment lang, no? Pag isang beses ka lang nag-try sa Anakem or sa any research, pwedeng tsamba lang yon. By chance lang yung value na lumabas. So if you want to make sure that your values are not by chance, but rather totoo talaga yon, yung value na yon, you have to do multiple trials, no? Sa thesis ko, natagalan ako. Bakit? Kasi triplicates ang data dapat. Bare minimum na yon, triplicates. Kasi kapag kayo ay nag-conduct ng research sa vaccines or what, you have to have at least hundreds or thousands of trials, no? Naririnig nyo naman yung mga ganong balita sa 'di ba? Sa TV, no? So for the laboratory, in a laboratory sense, no? Since college pa lang naman kayo, no? Up to 3 lang yung kaya. Up to 3 pwede na yon. And that is enough for you to see whether your results are reliable. However, pagdating nyo sa research field, it requires more than that, no? Kung kailangan libo-libong tao yung kailangan i-test just to come up with this result, kailangan gawin yon, especially with vaccines, because kapag hindi reliable results nyo, anong pwede mangyari? Mawala yung tiwala ng tao sa vaccines or pwedeng mag-cause yan ng harm, no? Ganun ngayon nangyari sa mga Pfizer vaccines, 'di ba? So paano nila nakuha na yung 95% effectivity rate, no? Kasi nag-trial sila sa tao. Hindi lang 3 tao trinay nila. Libo-libo, no? So ganun. So doon tayo maniwala sa vaccines or sa researches with with available data, with public data, mababasa nyo talaga yung results and mataas yung effectivity rate, no? So doon tayo sa mga ganung bagay. Huwag tayo doon sa mga hindi natin sure, no? Yung out of nowhere, ito yung result, no? So huwag tayo doon. So pag sinabi nating reliability sa Anakem, itong estimating their reliability, we are actually pertaining to statistics, no? Statistics. Tama ba spelling ko? Ayun, so basta yan. So that means yung Anakem, hindi lang siya chem. It also requires statistics, no? Pero for now, sa ating case, since ang ating ginagawa ay up to 3 times lang, up to triplicates lang naman yung gagawin natin, pwede na yung mean median mode, RSD, percent error, okay na yun. No, that is good enough for us, no, to estimate the reliability of our result. Pag malaki yung standard deviation, ibig sabihin mali-mali data mo. Ibig sabihin nun kalat-kalat yung data mo. Pag maliit yung standard deviation, ibig sabihin your data are close enough to each other, no? So ibig sabihin good yung research, good yung nagawa mo. Okay? So reliable yung results mo. Okay? So okay na 'yon. Pero kapag kayo ay magde-deal na with thousands of people, you have to use other statistical tools, no, such as t-test, ANOVA, no, pooled variance, no. Basta yung mga pangmalakihang tao, no. Kasi in statistics, depende yan kung maliit or marami yung iyong sample size, no? So, dun lang tayo sa maliit para basic lang. Matututunan nyo yung malaking sample size kapag kayo ay nasa biostatistics nyo, biostat nyo. So, di ko alam kung kailan yun. Next year ata, I don't know. Pero, madidiscuss yun sa inyo. And then lastly, pag kayo ay gumagawa ng chemical analysis, important ang feedback system. So, ano yung feedback system? Ito yung process in which you check whether your data are the same as the others, no? Hindi pala the same, similar with the others, no? Pare-parehas ba kayo ng result na nakukuha, no? Kasi to be honest with you, lahat ng laboratory sa Philippines, they are being tested every year, no? Parang yung molecular labs ng COVID-19, tinetest muna sila, 'di ba, bago sila bigyan ng approval. Okay? So bakit? Kasi without the feedback system, baka kung ano-ano na lang yung lumabas na results sa COVID testing, no? Kapag hindi yan pasok sa standards ng DOH, no? Sa nag-approve ng mga laboratory, baka mamaya positive ka dito sa lab na to, sa kabila negative ka. O mawawala yung reliability, no, ng inyong institution, no. So yan, kailangan may feedback system. Sa ating setup sa classroom laboratory, yung feedback system, hindi yan yung kopyahan. Hindi yan yung titignan mo, ano sagot mo dito? No, hindi yan yung ganun. Ang gusto mo na makita is that your results are similar to what others have solved, no? Given na same yung conditions nyo, no? When I say similar, hindi ibig sabihin nun kokopyahin mo yung sagot ng iba. Hindi. Yung yung idea na itong result ko ay nagkakaunawaan kami sa results namin, no? So good kami. Okay. So ganun lang. And then ito yung typical diagram ng feedback system, no? Start with your control, you give it to other laboratories, to other students, no? Sila magte-test, then after that, you check if pasado yung quality ng results nyo or not, no? So you will do it, no? Maglo-loop yan until everyone is able to come up, no, with a reliable result. Okay? So ganun lang. Tapos na. Salamat sa Diyos. Okay? So anyway, to sum up all this stuff, no? Tapusin na natin lahat ng bagay na ito. Ito yung mga ito yung mga important na alalahanin sa laboratory. Number one, wear your PPEs, no? Okay, hindi lang siya sa ospital, even sa laboratory. Pero compared to the hospital setting, yung PPE sa lab ay ito lang. Lab gown, gloves, pantalon, sapatos kailangan closed shoe. When we say closed shoes, yun, ibig sabihin nun, hindi expose yung skin ng paa mo, no? Okay. So, kailangan nakatakip talaga yung buong paa. And then, for the ladies, itatali yung buhok. Why? Kasi ito nangyari to talaga sa lab. Although hindi sa case ko, no? Narinig ko lang din sa ibang prof. Hindi ko alam kung saan eh. Pero ang kwento doon is may babae na nasunog ang hair. Okay? So mag-ingat kayo. Kasi yung hair nyo lumilipad-lipad yan, di ba? So kapag nasa lab kayo, itatali nyo yan. Ponytail nyo yan. Or you can use the hairnet, no? Parang magluluto lang tayo, no? Okay. Kasi mahirap na masunog yung hair. Sayang yung pagpa-rebond ninyo. And then, other than that, after taking care of yourselves, you have to take care of what chemicals are you handling, no? Kailangan alagaan nyo rin yung chemicals nyo. Kasi yung chemicals ninyo, it can cause harm. And worse, it can kill you instantly, no? So, you have to be very careful with the chemicals. So, in order for you to check kung ano yung identity ng chemical, you use MSDS, Material Safety Data Sheet. Andun lahat ng info kung ano yung pwede gawin ng chemical ninyo. Okay? So, bigyan ko kayo example, MSDS, ng acrylamide. Ito yung ginamit ko nung thesis ko. Nung nabasa ko to, natakot ako eh. Sabi ko, magti-thesis pa ba ako? Kasi nakakatakot pala yung aking chemicals na. So, pakita ko sa inyo. Ito yung itsura ng MSDS. Ayan. So, i-google mo lang, chemical name followed by MSDS. May mga PDF na yan. No? So, for example, ito, acrylamide. Then, the other names, to propenamide. No? So, ayan, ethylene carboxamide. No? Tapos, andito yung mga classification niya. Category 1, 2, 3, 4, something. Nakalagay din naman yan. Signal word, danger, di ba? Makita mo pa lang yan. Sabi ko, magtitesis pa ba ako? Ayoko na. Kasi yan, nandyan yung hazard statements, no? Toxic if swallowed, harmful in contact with skin, harmful when inhaled, no? Etc. etc. Yes, may mga ganyan symbols, no? So that means that it's poisonous and it can cause death, no? So yan. Tapos andyan din kung ano yung mga kailangan nyo gawin. If swallowed, call the poison center. If tumalsik sa mata mo, you have to wash it. Then punta kayo ng ospital, no? Et cetera, et cetera. So nakalagay lahat dyan ng info about the chemicals you are handling and kung ano yung mga pwedeng remedy, no? Kapag ikaw ay nadali ng chemical na yun. Okay? So yan, nandyan yan lahat, no? So yun lang. Pagdating nyo naman sa sa medtech lab, magaganyan din kayo MSDS, no? So hindi yan yung first time na makikita nyo siya. Pagdating nyo, pag kayo ay naging RMT, magsasawa kayo sa MSDS, no? Okay, so yan lang. Be careful with the chemicals. And of course, tools of trade, dapat familiar na tayo with them. Lab notebook, important yan. And balance, this is used when measuring the mass or the weight of your samples. Burettes, we use this to transfer liquids. Okay, and we read the lower meniscus as always at an eye view level, no, to avoid parallax errors. Volumetric flask, this is used to prepare solutions. Okay, iisa lang yung volume niyan because iisa lang yung kanyang graduation. No? Then pipettes, we use this to transfer small liquids, no? Small amounts of liquids. We do not blow the last drop, no? Hayaan mo lang siya tumulo. No? Micropipette, excuse me. Micropipette, this is used to transfer much smaller liquids, mas smaller volumes of liquids. Okay? So dalawang pindot 'yan. First pindot uh, will uh, will suck the liquid from your container. The second pindot, no, that will release the liquid from the pipette tip, no. Syringe, alam nyo na yan, syringe can be used to transfer liquids, no? Whether yan ay galing sa tao, galing sa hayop, or sa kung saan pa man, no? Or sa vials, no? Filter, sa filtration, we can use the Gush filter crucible. Ang meron sa Gush filter crucible is that it uses vacuum, no? Para mabilis yung pag-suck ng liquids, no? Okay, kasi kapag hindi kayo gumamit ng Gush filter, gagamitin nyo common filtration setup, itong itong gravity powered na filter setup, matagal yan, no? And we use the oven to dry our instruments. Bakit kailangan i-dry? Because of water, no? So si water yung umeepal minsan sa ating measurements. So we have to remove water, no? So after drying your instruments, you have to place it in a desiccator, no? Para good for use siya, no? So what's the purpose of desiccator, no? This is a container of your apparatus, no? Diyan mo ilalagay ang apparatus mo para hindi siya mag-absorb ng water from the air, no? Okay? Then lastly, kailangan natin matutunan yung calibration. Why do we need to use calibration? Because over time, our instruments are being worn out, no? Okay, nasisira yung mga yan, no? For volumetric glasswares naman, depending on the temperature, the volume changes, no? Because of the properties of water, no? Water expands and contracts depending on the temperature, so you have to account for that, no? Okay? Kasi pag nagbabago yung volume ng water, nagbabago yung kanyang concentration. Okay? Nangyari to sa akin, no? Share ko na naman. Anyway, 12 naman yung end natin. So, nangyari to sa akin kasi yung laboratory, 25 degrees Celsius. No? Sa Philippine Nuclear Research Institute ako nag-OJT. No? So, nuclear science yung pinagagawa namin doon. Although may chem doon. Gumawa ako ng solution na ganito ng sodium hydroxide. So, that's around 500 ml. Tapos nilagay ko siya sa ref. Pagliting sa ref, lumiit yung volume niya. No? So, hindi na siya 500 ml. As in, mga ano na lang, 450 ml. No? Mainit kasi yan. Tapos biglang nag-shrink. No? So, ibig sabihin nun, over time, depending on the temperature, your water will expand or contract talaga. No? Okay? Then, after knowing all the instrument, the apparatus, and the calibration, kailangan mag-calculate na tayo ng results and we estimate the reliability of our results using statistics. And hindi doon natatapos lahat, no? We have to use the feedback system to check whether our results are at par with other results, no? And with that, tapos na tayo. So, do you have any questions or clarification or okay na kayo dyan? No? By the way, sa mga bagong dating, no, if you were not able to pag di nyo naabutan yung first part ng lesson, i-upload ko naman to sa YouTube as always, no? So, yun. Panoorin nyo na lang ulit, no? Kunwari, nakatulog ka habang nagkaklase tayo, pwede nyo panoorin ulit sa YouTube. That's okay with me. Okay? Do you have any questions, concerns, or wala na naman, no? By the way, about the textbook, no? I just heard a word from the department. Yung textbook na Introduction to Analytical Chemistry, you can purchase it through Tom's Bookstore or C&E. Wag yung may access code kasi hindi na tayo gagamit ng access code, ha? Additional ano lang yan gastos. So, hindi na tayo magaganon this sem. And bibilhin nyo yung physical book na, yung libro na mismo. Okay? Tapos, ayun. Yun lang. Physical book daw yon. It costs 945 pesos ata, if I'm not mistaken. So, yun. Kayo na bahala if bibili kayo or not. As for my case, hindi ako muna magre-require. I don't know your finances. Alam natin mahirap buhay ngayon, mahal-mahal ng bilihin. So ako hindi muna ako magre-require ng textbook. Besides, we have the materials already posted naman na. Pero to be honest, I still encourage you to invest the books, no? Kasi if you can buy things from Shopee, no, yung mga kung ano-ano, pwede rin tayo bumili ng textbook. Why? Kasi important 'yan, no? Pagdating ng board exam, you will need to have books then, no? So, yun. Actually, may mga books ako ng chem dito, no? Nagamit ko siya talaga nung board exam, no? Pero during my college time, di ko siya nagamit muna Kasi we have the lessons then, no? Pero pagdating ng boards, sa libro na talaga ako nagbabasa, no? So, ganun. Baka makita nyo lang din sarili nyo sa ganung situation. So, yeah. Invest din tayo sa mga magagamit natin sa board exam. Okay? So, yun lang. Ito yung textbook na suggested ko. Although, hindi ito yung mga required. Hindi ito yung textbook na kailangan sa subject natin. Although, maganda to. Ito, favorite ko yan. No? So, yan. So, with that, if you do not have any questions, I think we're good for this day. So, I'll see you again on Monday. May holiday ba sa Monday? Wala naman ata. Okay, so I'll see you again on Monday. We will start our chapter 1, solutions. No? So please prepare your calculators with you kasi kailangan natin yon. And I will teach you shortcuts. No? Kung meron shortcuts ako, may share. No? So yeah. Thank you for your attendance. A copy of this class recording will be uploaded on YouTube later this day. No? So mamayang gabi upload ko siya. Okay? Para pwede nyo uli panoorin. Ha? So thank you and have a nice day. Enjoy your day. Salamat po. And ingat parate. Bye-bye.